So next, as we have intent to perform construction stage analysis for this bridge, so in MIDAS Civil, construction stage analysis can be performed by utilizing the different type of groups. Like if you go to groups tab, so you have structure group, boundary group, load group and tenant group. So by utilizing these groups we can form our construction stages. So for now we'll be defining the structure group, boundary group and the load group namings, and in the subsequent steps in these sessions, so we'll be generating the construction stages. So to add various structured groups, I'll right click here, I'll click on new dot and I'll give the name as first CS1, substructure and supports, click on add, change it to CS2, construction stage 2. Here I'll give the name as span 1, girders, add, stage 3, span 1 diaphragm, span 2 girders, so at last the cross beam for moving load. I'll define a group, click add. So these are all my structure groups. I'll click close. So I'll define the naming for my boundary groups. I'll click on new dot button, give the name as span 1 temporary supports, click add, span 2, bearing span. You can give the suffix like 1 space 2 and click add. So those two would be added based on the suffix, and give rigid link. So these are my boundary groups. I'll click close. Now I'll add my load groups. First self weight, ideal, superimposed dead load, span 1 pre-stressing PS, give the suffix as 1 2 3, click add, and similarly for span 2. So 3 indicates 3 sets of pre-stressing, that means 3 layers of pre-stressing would be done, so that's why I'm giving 3 sets. So for span 2 PS I'll click add. So these are my load groups, so I'll click close. So here we have defined the different groups. We did not assign them, we'll be assigning in the subsequent steps, like the elements for the structure groups and the boundaries for the boundary groups and the respective loads for the load groups. So thereby we can utilize all the structure, boundary and load groups to simulate our construction stages. So next I'll create the boundaries for my bridge. I'll go to boundaries tab, click on rigid links first. So here I'll enter the node numbers 44 to 67, press enter. So this got selected. I'll go to works tab, right click on the end diaphragm section and click on select plus. So this have been selected. I'll activate only them, and here in rigid link first select the boundary group name. So I'll be grouping the rigid links into these boundary groups. So these are the names. I'll select the respective ones, like rigid link span 1. I'll be creating first the span 1 rigid links first here in the program. So here you can turn on the node numbers, so you can zoom in. So I wanted to give 44 as my master node and 2 would be my slave node. A rigid link would be created in between these nodes. Click on rigid body, click on this master node number, click on 44. So this would be my master node number, and you need to manually select the slave nodes. For that I'll go to single select this node. So this would be my slave node and this would be my master node. I'll click on rigid body, so all these degrees of freedom would be restrained and a rigid body simulation would occur between the master node and the slave node. Similarly, I'll copy rigid link in the Y direction for this rigid links to be created in the Y direction. Distance is 3,3 meters. I'll click apply. So you can, if you don't display this rigid links, you can go to rigid link, right click display or undisplay. Click display here, go to isometric view. Similarly, I'll create the rigid links at this locations. So I'll change the master node to 45. I'll single select and select this node, rigid body, and copy rigid link in this direction for 3 meters, apply. So these are my rigid links for the first span. Now I'll change this boundary group to rigid link span 2 to create the rigid links for my next span. I'll select the master node as 50 and select the slave node as 17. I'll click apply. Similarly, I'll select the master node as 51, select the slave node, click apply. So these are my rigid links, and simultaneously I have grouped them under the different boundary groups. So I'll click close. I'll activate all and display the node numbers. I can display the rigid links. So next we'll create the bearings. So in MIDAS Civil, bearings can be simulated by this elastic link option. So I'll click on elastic link. So you can see here from node 1 and node 2 you have an elastic link. Based on this local direction of the link, you can specify the stiffness of this spring so that it will respond to the forces based on these stiffnesses. So first let me select the boundary group as bearing span 1. We'll be creating the bearings for the span 1. So that's why I've selected that group. So here you have different type of elastic links: general, rigid, tension only, compression only. You can give multilinear spring as well. I'll go ahead with general. So here SDX indicates the axial stiffness of the spring. So I'll give this value as 10 e power 8. I'll assume elastomeric bearings for this project. So as I have the stiffnesses beforehand, so generally that depends on the manufacturer of the bearings. So I'll give the stiffnesses as 2000 in the transverse directions. So if you want to simulate any pot PTF bearings, so you can change the stiffnesses. You can give this translation stiffness in any direction as high value, so that in that direction the bearing would be much stiffer. That means it's restrained in that direction. So in that fashion you can simulate the pot PTFE bearings as well. So I'll proceed with this stiffnesses. I'll give the rotational stiffnesses as minimum. Now here you need to select the two nodes in between the elastic link would be created. Similar way, I'll wanna copy simultaneously in the y direction. Give the distance as 3, 3. So I'll go to front view, single select. I'll select this part, click activate. Go to isometric view, I'll zoom in. Click on the node. Click on this node and the bottom node. So you can see here the elastic links 3 have been created. So you can right click and display. So these are my elastic links. So you can see this x direction would be my axial direction, and the y and z would be the transverse directions where the stiffnesses are given that I have specified. Next, at the other end, I'll create the bearings. I'll rotate. Go to front view rather. I'll activate. So these are my nodes. So these are my bearing nodes. I'll activate all. So this would be my two sets of bearing nodes for the span 1. Similarly, I'll change this to bearing span 2, the boundary group. Go to front view. I'll activate. I'll click close. So you can see here there have been 12 elastic links that we have created. I'll activate all. So these are my bearings. I'll undisplay. So next I'll define the supports. So I'll define the supports first at the abutment locations. So over here and at this end, I'll click on define supports from the boundary tab. I'll change the boundary group to bearing span 1. I'll restrain all degrees of freedom. That means it's a fixed support. I'll go to front view, single select. I'll zoom in and select this nodes, so which are 56, 58 and 60. I'll click apply. Now I'll change it to bearing span 2. I'll select this set of nodes, click apply. So here in meanwhile you can see in the tree menu too, like the supports have been created, the 6. You can right click and display. So these are my supports. So I'll undisplay. Next I'll define the temporary supports. So I'll change the boundary group to span 1 temporary supports. I'll unselect them. I'll restrain only dy and dz and rx for this nodes. So I'll zoom in. So these are my temporary supports for span 1 at the left end. I'll click apply. Select these nodes. I'll restrain dx for this set of nodes. Click apply. Now I'll change to span to temporary supports. Zoom in. Select this set of nodes. Click apply. Dx, apply. Click close. So now we have done with the support definitions, including the temporary supports. Next we'll define the boundary conditions of the substructure. I'll go to rigid link, go to front view, single select, select the substructure, activate, go to left view. So here I'll select these nodes. So this would be my slave nodes and my master node would be this. So I'll click on master node and select this node. So that would be the number. You only need to give the master node number, and the rest of the selected nodes would be considered as slave nodes. I'll click on rigid body. Be careful with the boundary group. So I'll change this to boundary group to substructure support, as I did not define it. I'll go to groups, right click here, give it as substructure supports, click add, close, select that boundary group, then apply. So go to works tab, so you can click on display. So these are my rigid links for the load to transfer from pier cap to the pier shaft. Next, to the load to be transferred from these bearings to the pier cap, we need to define the rigid links in these locations. So I'll select the master node, this one, and select the slave nodes of the bearing bottom nodes, and I'll click apply. Similar way on this side. These are my slave nodes, and the master node would be 40, this node. Click apply. Next, I'll define the support, fixed support at the bottom of my pier shaft. I'll not be modeling the foundation, so I'll go to define supports, select the group as substructure group, fix all, go to single select and select this node and click apply. Click close, activate all on display. So this would be my model till the boundaries. Next, we'll assign the elements and the nodes to the structure groups. So I'll go to groups. So here you have CS1 substructure and supports first. I'll go to single select, go to front view, turn off the hidden option, and then select the substructure part. You can just drag and drop it to the model window. So all these nodes and elements that we have selected would be assigned or grouped under structure group what we have selected. So this drag and drop method applicable to the material and the sections. So you can directly drag and drop the material properties as well as the sections. So those gets assigned to the selected sections. So it's very simple to assign the properties. I'll go to top view. I'll go to sections girder. Double click them, activate only the girders. So I'll select only these first span girders. I'll zoom and I'll select the first span girders, and then I'll drag and drop CS2 span 1 girders. So when you double click on those girders have been selected, you can inactivate them and activate all you have selected, and this would be CS3 span 2 girders. I'll drag and drop them. So this is how you can quickly assign the structure groups. Similarly, I'll activate all for span 1 diaphragms. I'll double click end diaphragm. By pressing the control key, I can double click end diaphragm to activate them simultaneously and click activate. So these are my end diaphragms. And the internal diaphragms, I'll select the span 1 diaphragms and drag and drop. Similarly, I'll drag and drop the span 2 diaphragm. I'll activate all. So you can check, these are my substructure, span 1, span 2 girders, span 2 diaphragms. Click escape to come out of the selection. Now I'll inactivate some of the structure groups. Double click, inactivate them. I'll inactivate the girders. You can press Ctrl and then select simultaneously two items and inactivate. So I'll inactivate them. So now I'll select only the transverse members, the dummy members of the first span. So I'll drag and drop the CS4 span 1 dummies. So I'll inactive and select the rest of the thing and drag and drop the span 2 dummies. Activate all. So these are my span 1 dummies and span 2 dummies. Now I need to group the cross beams for my moving load. So all these cross beams should be grouped under this cross beam moving load structure group. So I'll go to front view. So here you have an option. So you can select Y direction and go to single select the superstructure so that the Y direction elements only would be selected, and then I'll drag and drop the cross beams. So you can double click to check. So now we are done with the structure groups, and the boundary groups have already been assigned while we were defining the boundaries. Next we'll define the loads and simultaneously we'll group them under these load groups.